Hey guys, good to have you here again. This is Mr. B, your math analyst, and today we're going to continue. This is our fourth video from the set that we have about arithmetic sequences and series. In the first three videos, we were working with the concept of arithmetic sequences. But today we're going to introduce the complement of that concept, which is the arithmetic series. And we're going to start with notation. And this notation is called the sigma notation. So I hope that you are going to like this video and that it's going to be helpful for you. Let's see it just in a bit. Okay, so as I told you in the introduction, today we're going to start the concept of arithmetic series. And first, let's define it. So you're going to see here in the video the definition. Series in math is a sum of a sequence. What does it mean? Well, remember that a sequence is a set of ordered values. Okay, so the idea is that the series is when we add each of those values until a specific one. For example, if I say the series of the first 20 numbers, which in math is going to be annotated as S sub 20, what we're going to do is we're going to be adding the first term, U1, the second term, U2, U1 plus U2 plus U3 plus U4 until we arrive to the last term, the U20th. Okay, so that is the idea. But the notation is very difficult if we're going to write S sub 20 and we need to write U1 plus U2 plus U3. That is going to be complicated because sometimes we're going to have, for example, S sub 150 and we're not going to write all those numbers. So there is a notation that helps us to summarize this sum. And this notation is called the sigma notation. So in other words, the sigma notation, what you're going to see right now here, is a way, summarized way to write the sum of a sequence. Okay? And the first thing that we need to do when we are talking about the sigma notation is we need to understand how to interpret it. The very first thing that we have to do when we have the sigma notation is that we need to understand what each of these elements mean. Okay, and we are going to see here in front of the screens we have the sigma notation. The first thing is the sigma symbol. It is called like that because it's a Greek letter called sigma. Okay, and the letter sigma in math means summation or the sum. Okay, always you're going to have an initial value which is going to be indicated below the sigma notation or the sigma symbol. Okay, and that notation, well, as I said, is the initial value we're gonna start working with. For example, if the sum that we want to have is from the third term, what we're gonna see here in the value that is below is I equals to 3. Okay, and here in the top of the sigma symbol, what you're going to see is the last term or the upper limit. Okay, and then you're going to have, beside the sigma symbol, you're going to have the mathematical expression that we need to develop. Okay, basically is that. I think that is going to be clearer if we were with a first example. So let's go to the first example. Okay, so as you can see here, the first example has this notation, or is this expression that is written like this. Okay, and the first thing that I'm going to do with this is I'm going to give you the idea. So notice that here they are telling us that n is going to start with the number 1 and it's going to be increasing by one number until we arrive to 6. So in other words, first n is going to be equal to 1, then n is going to be equal to 2, then n is going to be equal to 3 until we arrive to 6, okay? And the idea of the sigma notation is the following. I'm going to try to write it in a way that is, I think, that is very clear to see it. So this is the expression we're going to work with for n, okay? And what we're going to do is first replace n by each of the numbers that I previously mentioned, okay? So 4 times 1, that is equal to 4. 4 times 2 is equal to 8. 4 times 3 is equal to 12. 4 times 4 equals to 16. 4 times 5 equals to 20. And 4 times 6 equals to 24. And now what we need to do is add all these numbers. I'm going to use the calculator. Okay, so 4 plus 8 plus 12 plus 16 plus 20 plus 24. Okay, and that is going to be 84. Okay, so basically this is the answer of this notation. Okay, notice that it is very tedious, okay, if we're working with all these numbers. So I'm going to show you a way to do it easier and faster, and that is going to be with our calculators, okay, our graphic display calculators. So hold on a moment, because I need to set something here. Okay, there we go. Okay, so what I'm going to do is I'm going to show you how to use your graphic display calculator with this sigma notation in order to avoid this tedious procedure that we need to do manually. Okay, so suppose, again, the same instruction, we already know what to do. So what I'm going to do is I'm going to, first I need to remember that I need to show my work. Okay, so I'm going to show the first two. Okay, 4 times 1 equals 4, 4 times 2 equals 8, and then I'm going to use this 3 dots or 3 points, which mean that there are other numbers that are going to come, and then I'm going to write this. 4 times 6 equals to 24. So with this notation, the evaluator that is going to mark my exam, that person already knows that I know the procedure. What I'm going to do is I'm going to take my calculator, and there's a key in the calculator that says math. Okay, so we're going to press math, and if you go to the option 0, okay, it says summation. You only need to press enter there, and notice that immediately I'm going to zoom in. So hold on, so you can see the calculator better. Okay, so notice that the calculator already has the sigma symbol there, and I just need to input the values that I'm going to use. So in this case, remember that the TI calculators, they use X instead of N. So I'm going to press X equals to 1, and notice that I'm just substituting the different values that are given in the problem. Okay, and then here the expression 4x, and I'm going to press enter. Okay, I'm going to zoom out a little bit so you can see the answer. Notice that the calculator immediately gave me 84 as the answer. So with this is super easy. Okay, so let me fix it here. So notice that with this I can demonstrate that I know the procedure, and it's just about replacing the calculator. So it's very easy when we have the sigma notation by using our calculators. Let's see a second example. Okay, so now we have this other example, example number 2. Okay, and I'm gonna write it first. It says expand and simplify. Okay, so notice that we have the expression, the sum from I equals to 1 to I equals to 5 of the expression 2I plus 1. And again, I'm just going to show first that I know the procedure, okay? So what I'm going to do, I wrote an equal sign. Hold on, let me see if this is clear in the image. I'm gonna zoom out a little bit so you can see better. Okay, so I'm just gonna take the expression and I'm gonna start replacing the values of I. Okay, so remember that I is gonna start with 1. Okay, so 2 times I, or 2 times 1 plus 1, then 2 times 2 plus 1, and then I'm gonna do the continuous dots. Okay, and then I'm gonna skip until the last term. Okay, and with that, okay, I'm gonna also add here the result. 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. And here 2 times 10, 2 times 5 is 10 plus 1, 11. Okay, so with that, it's better. And now, I'm gonna call the sigma notation in my calculator. Okay, I'm gonna input the values that are given. Okay, so in this case, x starts with 1 until 5, and then now is 2 times x plus 1, and then I just need to press enter. Okay, notice that the calculator is giving me the answer. This is 35. Okay, so basically I just need to write this, and that is enough, okay, to show my work. Okay, so as it is tradition here in our videos, the third example is an example that you are gonna pause, okay, and you're gonna try solving it. Then you're gonna play again the video, and we're gonna compare answers. So basically it says find the sum from starting from I equals to 4 up to I equals to 8 of the expression I to the third power minus I to the second power. Okay, so start doing it, pause the video, and let's see if you get the answer right. By now, you were supposed to solve this problem. Let's see if we are able to get the same answer. Okay, hold on, let me fix this here. Okay, so let's answer this question. Basically, the expression is here. Okay. And what I'm going to do, as I did before, is I'm going to replace. So 4 to the third power minus 4 to the second power. Okay, 4 to the third power minus 4 to the second power, that is 48. Okay, and then we have 5 to the third power minus 5 to the second power. Okay, so 5 to the third power minus 5 to the second power. This is 100. Okay, and remember to add the 3 dots, which means that we are continuing with this procedure until I equals to 8. Okay, so 8 to the third power minus 8 to the second power, that is 448. Okay, so now what I'm going to do is, as I mentioned it before, what I'm going to do is I'm going to input this information in the calculator. Again, calling with the math key. I'm going to scroll down until option 0, which is summation. Okay, and here what I'm going to do is I'm going to input the expression. Okay, so is x starting at 4 up to a of the expression x, I mistyped here. Okay, x to the third power minus x to the second power. Okay, so notice that I already input the expression. Okay, so I'm gonna press enter, and as you can see, the answer is 1070. Okay, and basically this is how we work with the calculator, or how we can solve problems that are written using the sigma notation. Okay. Remember, I forgot to tell you, remember that if you scroll down, there's going to be a link where you can click and you can download a practice about this. My suggestion is work in the practice, because the more you practice, the better, okay, for you. And also remember to ask any questions if there is a specific problem that you want me to solve and I am not able to answer it in the comments, then I'm gonna be solving it in another video, and I'm gonna attach it to this one. Okay, so remember to subscribe, remember to give a like to this video, and see you in the next video. Bye.